Hello everybody and welcome back to Differential Equations, Day 3. Today we will be doing something very simple. Homogeneity in solutions to first order linear ordinary differential equations. That is right! We are doing our first solution for our first type of differential equation that we'll be seeing. Alright, rock out. Okay, so, what is a homogeneous differential equation? So it's defined to be an equation where every single term contains the function or one of its derivatives. For example, we have the derivative of y plus y times a function of t is equal to 0. Let's look down here, for example. We have the derivative of y with respect to time plus y cosine 3t is equal to y. This is also homogeneous. And when you see homogeneous, you'll actually see it in the form equal to 0. And of course, we can group this here, subtract the y, and factor out a y here, cosine 3t minus 1 in parentheses times y here, divided by 12t to put it into normal form. But an example of a non-homogeneous equation that we see here, we cannot put this into two functions of y equal to 0. Sorry. Two functions of y equal to 0. Like we could do with these two, for example. As you can see, a non-homogeneous equation, derivative of y with respect to t plus y times some function of t is equal to another function of t, and that is what we see here. And the most key difference between these two, of course, we have y being cubed, but it's not equal to another function of y, it's equal to a function of t. So these are all first order, but are they linear and are they homogeneous? You will have to recall from, I believe, the previous lesson, if it wasn't the previous lesson, it was the one before that, on linearity of differential equations. So I'd recommend you to pause, and then I will display on the screen a star and a circle. If the star is green, or if any of the shapes are green, then it falls under the category of homogeneity or linearity. And I'll do this first one, for example. Look at this one. It is both homogeneous and linear. If we look at the derivative of y and y, they're all to the first power. So, perfectly linear, and then it is also homogeneous because it is not equal to any pure function of t. Now, I'd recommend you pause. I'm just going to run right through it. Boom. Boom. This one's neither. Fascinating. I hope you guys did really well on that. Feel free to rewind. Okay? Awesome! Now, it is time for us to solve our first type of differential equation. The very same type that follows the linear homogeneous first order that we were discussing previously. It's honestly quite simple. I'm stalling, to be brutally honest, because I really don't have anything to explain. It's just this formula. You must put it into normal form. It must be in this form, and you must not forget about this negative sign outside the integral. Okay, and also do not forget about the constant of integration. It goes here, because I'm going to be honest, I recorded this entire video, and I didn't have the constant in the formula, so I had to restart this part. Do not be like me, and do not fail, in that respect at least. Now, we are going to go and do some examples. Best of luck. I'll do the first one with you guys, and the next two I'd highly recommend you do on your own. Very good. So, dy dt minus 3y is equal to 0. Let's get to work. First thing we do is we take the, I'd recommend doing the, evaluating the integral first, actually. So, put this formula in, put it in the formula, minus 3, because you're just getting the function of t, you're going to negate the y. Y is equal to e to the power of 3t plus c. It's pretty straightforward. And of course, laws of exponents, e to the 3t plus c1 in the exponent. Well, we know that it's equivalent to e to the 3t times e to the power of c1. Rules of exponents, and e to the c1 is just another constant. So we could just multiply it by a constant. And that's going to be our solution. For the first one, I already clicked the arrow. pause and do these two. It's really not that difficult, especially once you get the formula. I'll give it 2 seconds and then I'll let it rip. Alright, very good. It's time to rock. First thing we do is we put it into normal form. Next, slide it into the formula, rock out the integral, and boom, baby. We're made. Third one, same thing. Put it into normal form, divide by 12s, and we rock. Easy. Even though this integral is a little ugly, it's actually not that bad because it's e raised to a natural log, and that's brilliant. It is totally brilliant. Because then the e goes away, it just becomes a term of s. However, you must remember that 3/12 is the coefficient to the natural log, so before we just get rid of the e in the natural log and bring this whole thing down, you must raise the argument of the natural log to the power of the coefficient, to which it is 3/12, which is 1/4, so it's the fourth root of s. And that is the end. Thank you very much for watching. The next one will be similar in the sense that it's, non-homogeneous equations of the first order, but it's just running and gunning with a formula. And very hypothetically, you could have just skipped to the end, got the solution, this formula, and you really didn't need too much. But if you want to do the examples, then they were there for you. Look, everybody, I'll see you soon. Bye.